This conference will now be recorded.
Go ahead and start at your convenience, Kash.
Okay. Hey, thanks everyone for joining, and thanks Bapi and the OCP team for letting us introduce ourselves. I've been following a bunch of wires at my previous company, and obviously for the last couple of years, and we've also had some exposure to UCIe. So we decided that a small group of us to start a new company about a month ago, and wanted to take the opportunity to at least introduce what we're trying to do. And as a quick introduction, we're sort of trying to really position ourselves and technology to be focused on an open chiplet market and developing solutions to address that. And as we talk a little bit further, I think that will sort of become clear. But that's basically the idea behind why we're starting something different. Okay. I think everybody in this audience knows that there's obviously a huge amount of interest in the die-to-die technology and the advantages that it offers potentially. And as we all know, the main market that's really driving this.
Presenting? Do you mean to have your slides and presentation with?
I thought I was presenting, so let me.
No. The question is, do you want to read in a slide sorter mode, or do you want to occupy the whole screen? We can see them.
Can you not see all this the screens all the way?
No, we see
No,
the slide sorter.
and they're not advancing either.
Okay, so I'm wondering why that is. Maybe do you see it now?
We see slide 3 now.
Okay, so if I know.
So it might be that your presenting screen and your other screen are swapped. That usually happens on Macs.
Okay, so that's probably why. I don't know. Okay. Any idea how I get around that?
Yeah, can you go to the bottom bar where you see notes, comments? Yeah.
Yep.
Keep going. You see the bookmark? Yeah. Click on that. Yeah. Click on that.
Okay. Do you see a screen? My full screen?
No, we don't.
Okay, I did click on that.
No, that's the presenter mode. Yeah, that's the presenter mode icon.
Yeah, so when I click on it, it goes full screen on my screen. It doesn't go.
Yeah, so I think what
screen.
we need to do is, I don't know which screen you're sharing. Do you have two screens?
No, I only have one screen, but let me. That will only leave the meeting. I have a little screen on the right-hand side that.
Yeah, so I think that is what is happening. If you see the little screen on the right-hand side, that's the one where it's showing the sorter mode slide, and that's what we are seeing. We are not seeing your full screen, which is what you need to do. So you need to swap the screens which you're sharing with us, and it will solve. So unshare your screen and then share the right screen with us.
Okay, I'll try.
No, unshare your screen on GoToMeeting. So we should be able to see your screen and then share your main screen with us. Yep, perfect. And now share your main screen with us and then go to the presenter mode. That should solve the problem.
Do you see my screen?
No, we don't, because you unshared it.
I unshared it. Okay.
Yeah.
Now, how do you want me to share it again? Okay. Now I share it. Okay.
You said you have two screens, right? So go to the main screen which you want to share. The one where you see the slide in the full mode, that's the screen you want to share with us.
yeah, when I'm going to click that and let me know if you see anything. Because it goes full screen on my screen.
Yeah, you got to
Sorry
swap
about that.
screens on your. That's basically what you're trying to do.
Okay. Yeah, it's
Otherwise, we can keep going in that mode. You just make your sorter left-hand panel to be very small, and your screen will automatically become big. That's good enough, Kash. We don't need to
okay.
spend time in. If it's not easy, just go with what you had.
Okay.
Now we
So
see the sorter mode. So you might want to start with slide 1. Double click on it.
yeah.
Perfect. And now take your bar and make it small. The left bar, which has all the slides.
Okay, how do I make that small? Okay,
Yeah,
just
there you
go
go.
to the left.
There you go. Yeah, pull it on the tab. There you go.
Okay, so you now see you
Yes,
can
we
it's
see it.
viewable.
And yeah, we see it. And what you could do is you see the after the next to the slider, the presenter, you see a slider bar plus minus. You can make little bit plus. Yeah. Yep. No, that's too much. Keep going. Keep
Okay.
going. Yeah. Perfect. Thank you. No. Perfect.
Okay.
Thank you.
All right. Thank you so
All
much
right.
for walking me through that. Okay, so I think we're there, and now you can. So if I play this, do you see full screen now? Does that work?
But it's good, big enough.
Okay. And do you see slide 2, which is
No,
what
you're
the
probably
problem?
one. Just get out of the slideshow and just go. Forget the slideshow. Just
Okay.
you're probably better off. Yeah, now it's slide
Okay.
2.
So okay. All right. Thank you.
You can see the next slide now.
Okay, so you see that slide. Okay, so what I was trying to explain was, okay, but the real focus right now still is obviously on high performance compute. But our view, at least long term, is that this technology will also need to sort of flow downhill towards the regular market, right, middle performance. And one of the problems we see is that with these old, innovation and new standards, there's obviously incompatibility, and even though they're very similar, the bump maps are different, and they vary even from standard package to advanced package. So and the other thing is, at least from the IP vendor standpoint, the current vendors are mostly ignoring this low to mid performance market, and that's why we started your chip. So very quickly, just trying to explain the differences. As you know, both UCI and bunch of wires are great for high performance, but it is expensive in terms of area. And the minimum performance, as we know, is 16 bits wide and 64 gig, and they now go up to 32 gig or plan to go to 32 gig per link, which gives you 500 gigabits. So it's great for AI, ML, etc. But there is a cost that comes with it. So if you take an RX and TX, it comes to about 1.6 millimeters in area. And in the real world, there are chips being built where the whole chip might be 3 millimeters or 4 millimeters or 10 millimeters on an area. So this area starts to be a big factor for a certain percentage of the market. And typically, most designs right now that are being implemented, they don't really feature older technology. They're all targeting 7, and I noticed that one of the big companies announced 3 nanometer tape out. So there's still a lot of interest that I've seen in some older technologies. So that not everybody is trying to rush to the most advanced bleeding edge technology. So where do we try and fit in? We're trying to fit in with a more flexible solution, which you can employ down to 4 bits and 4 bits wide, And we're sort of decided after talking to a few customers and partners that 1 gig seems like a reasonable speed to be able to try and support for the lower to mid performance marketplace. We've added a couple of, so we will still support obviously the higher pin counts and bit widths, but we are trying to do something at the lower end because we've seen some interest in that area. The other thing that is a little bit different is we do have a mode for cut through latency where you don't use the serializer deserializer, so that you can operate at the same clock speed as the device itself. And the advantage of that is that you can have a lower latency, right? So if you're running at 1.8 gig, you could potentially run the link at 1.8 gig and get everything through in 1 clock cycle. Therefore, you have a very nice latency. That's appealing to some customers that are purely doing, they're splitting a die into 2 or whatever, and they don't need massive bandwidth. So that there's a specific, maybe a niche market for that. So what this means is that we can have an RxTX, which is substantially smaller in terms of die area and die cost. The other thing that as I've talked to customers is there is, I know there's this all talk about advanced packaging, but there's a lot of trepidation about even an organic interposer, and they're really there's some concerns there in terms of life and reliability and so on and so forth. So that is a factor of why we're initially focusing on 12 nanometer as our first implementation. We have heard a lot about security, so we have built in a PUF security block into our PHY itself, so it becomes a no-cost option to the customer. Very quick summary, not really want to get too specific on this, but we are trying to be able to mix UCIe and bunch of wire support so that the customer doesn't, if you're an end customer, you already know what you want. But if you're trying to develop IP, as I mentioned, for an open chiplet market, you've got a problem, right? Which is, what do you support, and how do you want to make something that it's going to cost you millions of dollars to develop, and you want to be able to sell it to as many people as possible. So I think that's one of the key driving factors for what we've tried to do. And I'll talk a bit later on about our flexible bump pitch technology so that you can support both advanced and standard packaging. I've talked about the flexible width already, and then I'll give the reasons later at later slides about why we've added PUF security in the PHY itself. It does help us with some security functions, but the key advantage is it allows us to implement a known good die solution, which is a hot button for me because a lot of people are ignoring it. But if you do have chiplets, and maybe it's 5 years from now that are from multiple vendors and they've been sitting around, how do you, who's responsible? I mean, we all know the discussion, but people do sort of kind of hide it, and we've tried to address it up front. So for mass adoption, we're taking an approach which is for early customer partners. We're basically offering our IP at very little cost just to get established, especially if they're developing open chiplets, because we want that whole system to come up and running. And for key IP, which is sort of strategic, we're actually partnering with a number of IP companies to develop specific chiplets. So we are going to actually develop those so that eventually in a few years there is actually an ecosystem. Everybody keeps talking about an ecosystem, and it's clear that there's not going to be magically all these chiplets appearing for open use. So different groups are forming little ecosystems. So we're sort of involved in sort of setting up one of our own. And just to summarize why somebody might want to use off-the-shelf chiplet is obviously for developers, because if the developers don't win, then you've got an issue. We can share that we are doing an FPGA-based chiplet, so we think that'll be attractive to customers, so that they can even prototype their design, and then they can obviously migrate that to a full ASIC. And use off-the-shelf chiplets for I/O, or they may decide to do a full ASIC, right? Or they may do a hybrid approach later on, right? Start with a mixed solution and then go full SoC later on. So we think that off-the-shelf chiplets, the key premise here is, and the key advantage is, it's not really cost, it's time to market, it's lowering risk, getting the customer to market quicker. And as we all know, you can develop a product and it's missing some features, and you then have to go develop another version. So if you can go through that cycle quicker, you win from a financial standpoint significantly. I won't go into this specific slide, but I think this will give you an idea of the key IP chiplets that we're in discussions with. We do have a deal with QuickLogic to use that technology when we tape out, and then we're pretty advanced on a RISC-V partner. They do have functional safety built in and support ASIL, so it does seem like a very good multi-use for the sort of market that market segments we're targeting. And then we are targeting some popular IP, right? DDR, PCIe, and Ethernet, and we're in discussions with vendors that have PHYs and controllers and whatever in this space. So we think that this is sort of the minimum level of ecosystem needed to get people to start using open chiplets within a system. So talking about known good die, so what are we doing that's different, right? Is let's say that you've got 4 different chiplets and they're from 4 different manufacturers. They may be in different nodes. So what we have done is we've built an approach where when somebody uses our PHY, it has a unique manufacturing code, very much like a UPC code, right? So the manufacturer, the particular product that should be part of that. We also embed a PUF, and what it allows us to do is get a unique chip ID. And we also have some process monitors in the PHY, without getting too much into detail. But we're also doing an approach where you can probe that. Let's use a bunch of wires in this case, right? You can probe with one probe card that PHY and be able to test that die. So you would know the unique ID of the device, you would know the UPC code, you would know the particular ID, and in real time you could actually test that data against manufacturing data if it's available, to know if anything's changed while the device was in storage or at a distributor or however it was, right? So I think that's one of the key things. But the other key thing is being able to easily test these disparate die, right? So if they all had Unify, and it was a bunch of wires, for example, it would be the same probe card, right? So you just test our port and you're able to test that device. You're able to know when it was manufactured, what test results they had. So we're this is not a full manufacturing test, of course. This is to know that the chip is still functional, if any of the parameters, major parameters have changed, and if it was tested good, ideally, right? Because nobody, right now, the big issue is who stands behind whether the chip is, not the chip, but if the final product, let's say that you find that device from manufacturer chiplet 2 is bad, right? So everybody needs to know, right? Then they get you, then you can have a conversation. You can say it was tested or it was not tested, who's responsible and how do we get better? So I think this from our standpoint is actually maybe something nobody cares about today, but I think it's longer term. I think we have an approach that I think could be of interest to our customers, which is they want to build open chiplets and they want to make sure that there's a way that they can be tested before final assembly and final manufacturing. The other reason to obviously use the PUF is for security. So we have a very simple approach. Did that slide? No, yeah. My right-hand side is covered, so it's tough to. So we have an ability with the controller version that we're doing, where when the chips first come up, the links talk to each other, right? So if you have PUF on both sides, you can do a number of things, right? You can make sure that there's been no tampering on the device itself, because the PUF of the link across from you should match. And we could also start to get an idea of if there's a change to the PUF. Let's say it's a minor change, it could be aging, and so you can start having some capability to monitor this. So as you know, there's currently no standard, but for die-to-die link security. But this was one of the reasons why we put this in there. So I think it's something that is very simple. We're not trying to do like mill grade security or anything. We're just trying to see, hey, did anything go wrong? Is the part that was there when it was tested originally still there, and is it functional? And is it the actual device, right? So we think that gives us, I would say, pretty good security from simple tampering or somebody using illegal devices or anything like that. And then
Sorry, Cash, one question here.
Sure.
Because you are delivering soft IP, if I understand correctly, how do you manage the statistical beyond PUF?
We are delivering hard IP we are delivering hard IP for the PUF, for the PHY.
Okay, got it.
Yeah, we're not just doing the controller. We're doing a specific PHY architecture.
I got it. I got the impression that it might be soft IP. Thanks.
Okay. And then the other thing that so I want to make very clear that this is for illustrative purposes. Okay. And obviously there's a lot more detail to these, but essentially a number of people have asked, okay, is this BS where you can mix and match or support different? So this was one of the key ideas that we had. So we wanted to at least in generally explain what we're doing. So with more advanced processes, as you know, the bump pitch hasn't really gone down much, but the technology, let's say from 40 micron to even 12 so the devices have really gotten smaller. And so basically the active area of the drivers and whatever naturally for a die-to-die type interface are relatively small, which is one of the reasons why you can do advanced packaging, right? You can go 35 micron bump pitch, and which means that each your drivers and everything will fit one of these small areas. So for illustrative purposes, we're showing in fact 6 tiles here. Let's say that it's standard U, TX, and U, RX, and B, TX and ERX, and obviously power ground and clock, right? So you basically have a sea of these, depending on how big and wide you're going to support. And now let's say that this one bump you want for standard packaging, you obviously have a metal top pad layer, and then you can connect using, very simply, an interconnect layer to connect to, let's say, the UTX, right, which is the standard U, the TX of that. So this bump then becomes, and then obviously the bump goes on top, right? So with very simple metal changes, let's say you do a product which is a bunch of wires, standard packaging, you might have be able to do something that, not using this specific illustrative design, but we're trying to give you the concept, not of exactly how we're doing it, right? So with a very simple change, you can select, for example, what this bump is, right? So currently, I think most people are doing, hey, this is a power bump or a ground bump or a TX or an RX or whatever. So we're doing something a little bit different. And we want something that you can change the bump map and the pitch easily, and select, depending on which standards you support, you can select what that driver is going to be, right? So so you have you minimize the amount of investment that someone who's trying to make a general purpose chiplet has to do, right? Which is, so we hope that if you know, that this will give us some advantages over over people who for customers who are looking to do this. And obviously, each tile can have more than just URX. I mean, you can imagine that this tile also has, for example, TX and RX in here as an example, right? So it can do different things. And the pads can go across. I mean, I've talked to some customers for older technologies where even 130 is too, I know it sounds really strange, but you know, they wouldn't mind 160 or 180 or something. So in theory, you could even support a customer if they wanted a wider bump pitch if they needed. So I think that is a quick intro.
Sorry, can I ask a couple of quick clarification questions on this?
Sure.
First of all, what's the difference between UTX and BTX?
UTX is a standard that starts with U, and BTX is a standard.
Okay, so UCI are a bunch of wires. Oh, right. So this is
exactly say that, but yes, you could assume that.
Okay. So this is, do all these exist in one go, and you just bond out one of them and the others are dark? Or I'm trying to understand, this one pad is obviously, you can't get pads on the other 5 tiles. So what am I missing there?
So what you're missing is that the tiles, these are little tiles that contain that driver. Let's say the TX for UCIe, or for the U standard, I'll say use U standard, okay? And it fits the area of, that's why it's explained that this is 130 microns, right? So let's say that you want to have a TX bump, right? So now here's your metal bump pad, metal pad here first, right? And then you see these connections here to the lower level.
Right.
See this?
Yeah.
Right.
I understand that, but now I can't get pads to the others. So they're just dark silicon, or are they different types?
Yes, exactly. No, they're different tiles, but they're not being used. Right.
Okay. So you're wasting silicon effectively, but you have to because of the bump pitch anyway.
I think you've captured the point. Yes. So with 130 micron bump pitch, you are basically wasting a lot of silicon area because the drivers haven't scaled, right? So yeah.
But if you're at 45 micron, do you then only connect to one of those paths?
Exactly.
So in advanced packaging, you get to pick the one you want through the bonding. And then if you're in standard packaging, you attach to all of them, and then somehow through some sort of fusing, you're turning off the ones that aren't being used, including power. That one I find hard.
Well, power is, as I said, this is for illustration. As you know, power is a sheet that's everywhere, right? So this is more just to make it simpler for people to understand. The reality is that, well, yeah, I don't want to get too much into the details here, but the idea is
you got a bunch of engineers on the call. You got to get into details. Sorry.
Right, but the idea is that you, yeah. So let's assume that we had 3 of those UTXs up top, right? Just for argument's sake, right? Then in advanced packaging, you could have, you know, obviously you would only have the middle one, but then as you say, for 45 micron, you would have 3 separate connections in the same space, right? And or in reality, exactly. So you could do 6 if let's say everything was in one tile, right? U, B, clock, BCC, whatever, right? Then you could have 6 of these versus 1 of these, right? So, but you also have an interim capability where you only maybe use 4. So if you look at, let me go back to this slide, not this slide, this slide. So the engineers among you could probably figure out what we're doing, looking at that, those numbers. Right. So yeah. Okay. Any other questions or comments? So we're just sharing kind of what we're trying to do. And we have seen a bunch of confusion from customers about what is UCIe and what is a bunch of wires and why one's better or not better. And we've tried to explain, hey, you know, they've got, there are some advantages of both. But ignoring which is better, I think it makes sense for a client if they can use the same core design and be able to support, you know, different bump pitches as the technology moves, right? And also as the standards go, right? So yeah, that's basically why we're doing what we're doing, and what the basic technology ideas are behind what we're trying to do.
So
okay.
There is
Any other
something
questions?
I'm kind of confused. I'm not able to reconcile. Maybe confused about the wrong word. On sort of one vector, you're going, hey, we've got customers who are sort of at 130 and 160, etc., or whatever the more mature process node is. How are those customers trying to choose between UCIe and Bow? Because UCIe at least is just concentrated like crazy on the upper end of the speed. At least Bow has these, you know, lower end modes. And how is it that someone who's on 160 is thinking about UCI versus Bow when I don't get that? I'm finding hard to reconcile those two statements.
In which yeah, so I think that this is getting into a philosophical discussion, right? There's nothing to stop somebody from running UCIe in an older technology like 12 nanometer.
But
right?
who will they connect to?
Well, they can connect to
because the rest of the world is on UCIe at whatever. I'm simply saying at least UCI, you're almost going to create a proprietary private family. I mean, which standard you use almost becomes less relevant, right? you're going to create a whole bunch of slow parallel interfaces. Not that it's a bad thing, but it's not clear to me why there's this. Okay, maybe you could explain why there is a big debate on UCI versus Bo at that speed.
I think what we're trying to say is that we do support UCIe and bunch of wires. I don't think our technology will support 32 gig, at least per link. I think we can get to 16 with 12 nanometer, 16 gig per link. And UCIe, as you may know, does run as low as 4 gig per link, right? So it's very similar to a bunch of wires. And
no, I mean, take out UCI and Bo. Just what's the benefit of at that? Is it worth paying the tax of being compatible to either of them if you're sort of creating your own private family? Do you have that?
What's the tax? I didn't understand.
Well, fundamentally, you're going to presume, at least with there is some degree of compatibility, right? If you're claiming UCI compatibility, you're going to run a compatibility test set. If you're claiming Bo compatibility, which is a different thing, right? So you're going to be compatible, and I'm trying to sort of understand at those speeds what you see as the upside of compatibility. It's more a question, not a comment. What do I get if I'm running at these super slow speeds? What do I get for being compatible?
Well, I don't know which super slow speed. Are you talking 4 gig or 8 gig or 16 gig? That's super slow.
At 160 at 130 micron, 160 micron, I'm going on these mature nodes.
I think this
is
technology,
the vision that these things go off and will be sort of peripheral chips to complex CPU chips or something? What's the sort of system level model?
Yeah, so let's say that you have a 3 nanometer core UCIe chip or bunch of wires chip, right? You may want to, for example, have PCIe Gen 5 port, right? And that PCIe Gen 5 port doesn't necessarily chiplet, IO chiplet. You don't necessarily need to build it in 3 nanometer, right? Because the mixed signal isn't really scaling that well. And you may want to have different numbers of those. So both bunch of wires and UCIe have the concept, for example, of IO chiplets and so on, right? And we are seeing some interest in customers who are even interested in lower speeds than what bunch of wires and UCIe can do. So we're doing two things. We're trying to be compatible up to 16 gig per link. And what we're saying is that there is more work for us for sure to develop a UCIe and a bunch of wires, right? But once you develop them, it doesn't, for the standard packaging, it doesn't cost you any more. For advanced packaging, I'm not sure we can scale this much beyond 40 micron, but that's seems like a reasonable bet, because once you go much below that, people are going to do hybrid bonding, and that's a completely different world in terms of the particular interface that people are going to use anyway, right? So I haven't heard anybody anyway. So I just want to make sure that there isn't a penalty for standard packaging of using what we're doing. So if somebody's doing 16 gig per link, it's the same area, right? So yeah, and we do plan to support more advanced processes. We're doing 12 initially, and then we are going to do 40 nanometer because we have some people that want to interface to things like higher voltage stuff and other devices. So those are the two things that are on our radar initially. But yeah, there's nothing to stop us going and doing 3 nanometer with this technology or 5 nanometer later on. we've made a conscious decision not to go in that direction, because you've got Blue Cheetah, you've got Alpha Wave, you've got Synopsys, you've got Cadence and GUC. I mean, there's so many people who are chasing that whole data center space, right? That initially we're deciding that maybe we're better off chasing a slightly different this midterm area. But and frankly, this, depending on who you talk to, this is a reasonably significant market. So I'll just leave it at that. Any other questions? Okay, so you got your 10 minutes, Bapi.
Thanks, Kash.
How do I stop sharing? Are you going to take care of that?
I think you just hang on.
Click that.
Yeah,
So I've
there you
stopped
go.
sharing. Okay, hey, I managed that. Amazing. Thank you.
Okay. Well, I won't take up the entire 15 minutes. We've had some discussions on and off about assembling a response to the CHIPS Act. I mean, there's a lot of unknowns: how we do it, who we do it through, what we do, etc. But is Marek on? He was on somewhere.
Yeah, I'm on.
Yep. All right. So one of the things that happened with the business group last week was that the business group doesn't seem to be the right venue to assemble a response, because it requires a lot of detailed work, and it's likely outside the scope. So if we want to assemble a response to the CHIPS Act, if we want to say propose something in packaging or any other activity, it'll be a temporary activity that we will have to fork off as a separate group. So Trent, who was the most interested, I had one more response yesterday from another person who's not online here. And then I think John Schaff has got some interest in supporting it. So I'm going to do a quick poll on anybody else in that bucket of, hey, we're interested in doing something with the CHIPS Act. Then I'll call a separate meeting and see if there's a there. Is there anybody else online who's interested in this? I'm going back to our notes from a couple of weeks ago. Let me see who's. So that's basically it. So the short version is we have to do a separate meeting if there's enough interest, and maybe report back, bring it back through the business group periodically. But is there anybody who's interested in saying, yep, I want to burn some cycles on the CHIPS Act? And if the answer is no, then we don't have to do anything. We can go sort of figure it out independently. But if there is, now is a good time to speak up.
Copy, this is Quinn. I would be very interested.
Okay. So Quinn, John Schaff, me, Trent.
I've already expressed interest. Yeah. So.
Oh, okay. Let me. Sorry. Let me do one thing. Let me take. I'll call a separate meeting.
Yeah, I'd be interested.
Kash, Quinn.
Bapi, please include me, Pratyush.
Pratyush.
This is Shahab. Bapi, please include me too.
Sorry?
This is Shahab. Yeah.
Okay, so I've got Kash, Quinn, John, Pratyush, Shahab. Who else?
Bapi, probably you want to include me too in case there's some way the OCP can support this or should
Right.
support.
Okay. So Kash, Quinn, John, Schaff, Pratyush, Shahab, Cliff. Did I miss anyone? Alan. Okay. And then I had Trent and I think somebody from Samtech. Okay. Oh, I know. Okay. Then we're likely to get some participation from the incubation firm. Okay. Anybody else? Anybody else's firm? Anybody else's company is that they're thinking they'd be interested in this? Okay. Then I will reach out to everybody who's interested in a separate meeting, and we'll see if there is a way to collaborate on this. Let me do a quick round of, since we have a few minutes, let me do a quick round. Quinn, Mark, any opens?
No.
Shahab, Steve?
Nothing, thanks.
Oh, Shahab, that's right. That you said, since you're on, we have to find a way to revive I've gotten a lot of interest on the data spreadsheet, and so we have to find a way to get those meetings moving again.
Sure.
So
Let's chat about it.
hopefully, huh?
Yeah, let's chat about it. I think we do have a time slot on Mondays. If you want, we can start meeting on that.
Yeah, we do have some critical mass on those meetings now.
Good.
Okay, Steve. Kash, Hasham, any opens? John, Cliff?
I'm good, thanks.
Cliff, do you want to do an update on the, okay, I've seen you on the PR, but we can wait till you're back, I guess.
Sure.
Mike, David?
No, nothing.
Nick? Alan?
I'm good.
All right.
I'm good. I did try to join the spreadsheet one. So yeah, that'd be good to
No,
get
we're going to. So we're kind of going to mix thing. We'll find a way to revive it. There's a lot of interest in this sort of. It's sort of grown out of nowhere.
Yeah.
John, Craig.
Nothing from me.
DJ, Marek.
Nothing from my side.
Yeah, nothing on my side either. Thanks.
Okay. Michael.
Oh, it's okay. Thank you, Bapik.
Okay, nothing from me. Thank you.
Suresh, Pratyush.
Thank you, Bapik. Nothing.
All right. In that case, we're done. I'm going to leave the bridge on so that we don't have to restart it for the next meeting. Have a good weekend and everything. So the next meeting is a business meeting in 10 minutes, 9.
This conference will now be recorded.
Okay, so welcome everyone to the business group meeting. For today, I first wanted to review the voting that we had done last time on priorities for the business group. Then wanted to give you a quick overview on where I'm keeping the documents for the business group, and then we can talk more about the chiplet use cases. Last time we've done both a list of general chiplets that would be interesting for a marketplace to have, as well as applications. And so what's left to do there would be to map out which chiplets would be needed for what application, and then prioritize down to 2 or 3 top use cases, and then starting to analyze those use cases. Okay, so I'm gonna share my screen here to just show you again the voting that we've done last time. So the options that we talked about last time were these 6 ideas of what we could be doing in the business group. The first one was to define top chiplet use cases and then prioritize them and look for ways how we can then work out solutions for those cases. The second one was to work towards a white paper for the business challenges that had come out of the main ODSA meeting, and I presented a summary of that, I think last week it was at the general meeting. There's a link to that. There was also the idea of this chiplet checklist, but again, that may need input from understanding what kind of use case we're talking about. There was an idea to work on business case best practices in a way to help how we can give people some guidance on how to review ideas and if they're worth to turn into a chiplet architecture and what that would imply. There was the question of working up proposals for the CHIPS Act, but Bobby just talked about this. There's going to be another subgroup that he's going to put together. So I guess this one we can officially exclude here. And then lastly, one thing that I was interested in is to help make information from the ODSA a little bit more accessible through, say, the wiki or the website. So after voting on all of these, the one that had the most amount of traction, I would say, was to work on these chiplet use cases, and that's what we're going to do later today. And then followed by the business cases, and I guess otherwise in terms of like high counts for medium priority, there was also organizing the ODSA information. So does anyone have questions on this or feedback? There may have been some people that weren't present last time, so yeah, feel free to ask any clarifying questions. Okay, so then I assume this is reasonably clear. So then the other thing that I started was to put together like a folder structure on OneDrive to keep or access to some of or have access to some of these information that we're compiling. And I sent out those folders already last Friday in the email. So what I've done so far was to create folders in my drive here and gave everyone read access and commenting access. And for things that we want to work on together, I could also add people to be also authors on documents. What I tried to do was to have one folder where you can go in to for the meeting notes for the various business group meetings, and in the meeting notes here at the bottom at the end of the meeting, I'll put in a link to the recording, as well as links to related documents that we may have talked about, so that you ideally have everything in one place and you can just look at the agenda to have an idea of what was talked about and then kind of go into more detail if you want to go back on some of the things that we worked on. So that's number one. And then I started creating project folders for the things that we've discussed, and there may just be one or two files in here, but for example, in the chiplet business challenges, I added the presentation that I presented at the general meeting so that you can look at that, as well as some of the other presentations that Bobby sent over to me. I don't think we have the files from everyone there. Is that right, Bobby, or do you have more presentations available?
Not to my knowledge. I think I gave you everything I have.
Yeah, okay, that's fair enough. Yeah. So if you guys want to find anything, then I'll keep including these links in the meeting minutes afterwards, so that it should be hopefully an easy way to get access information. And this is kind of, at least for me, kind of a blueprint how I'm thinking about how we could maybe also have other OneDrive or like other like folder structures organized with like kind of the top level information, say from CDX or other groups, things that people would like to just be able to look up. Any questions on this? Okay. So then we can go to the chiplet use cases, and I can quickly review where we stand with this today, and then we will definitely need some more discussion to flesh this out and actually narrow it down to the top 2 to 3 use cases that we want to use as an example to then analyze business challenges. So what we had started last time, or towards the second half of the meeting, was to look at chiplets of interest, and the things that I've noted down so far was to have chiplets for AI accelerators, IO chiplets, FPGA accelerators, interface converters from, say, a die-to-die interface to a more long-reach interface, compute chiplets, data converter chiplets, memory chiplets, switch chiplets, hub chiplets, as well as NOC chiplets. And then ultimately, we're looking more at the chiplet applications and some like top use cases. So these were some of the things that we had collected last time to have. Like one application use case of chiplets would be supercomputing, where you build like really big systems. We had video transcoding as one, I guess, like specialized application. Healthcare as an idea, but the comment came up that that is pretty regulated, so it may not be the best starting point for like building a chiplet economy. We had IoT or edge applications, automotive, and sensor fusion was mentioned as one of the reasons why you would want to have chiplets there. Then use of chiplets in data centers for networking and for storage. And one of the things that Cliff mentioned was that once we have these lists, we should also think about how we want to select our top chiplet use cases. And he made a couple of good points that we should have a kind of like cases that are pretty broad and cover a lot of aspects. So it would be good to have use cases that both represent die disaggregation as well as integration as kind of two separate motivations for using chiplets. It would be good to cover both high and low end applications. One lower end one could be automotive, for example. And then John had mentioned last time that there's also, you can think of chiplets in an ecosystem in two buckets, one being table stakes chiplets, so things that everybody needs but nobody's going to derive a lot of value from because they're just assumed that you have them in your system. And then that there would be differentiated systems, and this is probably differentiated chiplets, and this is where you would get specialized chiplets where, like, say, a certain company has experience in building something really well, and then that's what they would do.
Eric, I just want to suggest I have another criteria to think about.
Okay, sure.
Because for me, this is not really worth doing if we're just going to look at individual chiplets.
Yeah.
I think what we're trying to do is look at use cases where it's a system in package, and I think, are we looking at, would we have a criteria about how many chiplets are in the system in package? Are we looking for use cases with at least 3 chiplets connected together for a system in package?
Yeah, I mean, I guess that's more forward-looking, but I think that's like we could do that, yeah. So at least to note down how many chiplets are we talking about.
Yeah, so if it's just a single chiplet in a system in package, I don't see how that's exciting unless I miss my mark.
Yeah, well, are you talking about, like, well, I guess like at the minimum there would be 2, I guess, otherwise it wouldn't really be a chiplet system to begin with. But I see your point that even 2 is kind of like is that the problems start getting more if you start having more chiplets in there.
Is that enough? That's all I'm asking. I don't know the answer, but is that a criteria? Yeah.
Okay. Other comments?
Well, I mentioned this last time, and again, another teaser. I'm going to present a 3-chiplet SIP case study at the OCP Regional Summit. And I don't know, Bapi, do I have a slot next week or the following week? At
the week after
Friday?
next, 28th.
Okay. So the point being, as you mentioned, 2 is minimum, 3 starts to get very interesting. From that point on, one example I can think of is the Ponte Vecchio from Intel has 47 chiplets, but the total count is 63, including some thermal tiles and so on. There are plenty of examples that the big guys have done, we can even start there and say, if you're not a big guy, how do you put such a system together? And that's as good a use case as any in my mind. Otherwise, we'll need input from system architects, or in terms of what kinds of reference designs or types of, for these markets that we've identified, what kind of chiplets make sense in terms of, or even what functions you would require. I think that's super critical. And if I can grab the screen for a second, I want to just throw up one slide.
Sure. And just let me unshare here and give you the sharing rights. Okay.
Share my
You should be able to share now.
All right, I'm getting there. Can you guys see my screen?
Yep.
So this is a talk titled Chiplet Nirvana from Hip Chips. This is presented by an AMD guy. It's a pretty interesting talk, and I would recommend we all take a look at it. But basically, this has been kind of AMD's thing where they had proprietary thing called Infinity Fabric, and they connected up multiple of their own proprietary chiplets. But now they're starting to look at bringing in third-party chiplets like photonics, Ethernet controller, and those are all based on UCIe. So they're asking the question, we've been doing this, and what they're trying to bring in is create an ecosystem, and they're going to bring in third-party chiplets, and the UCI standard in their mind is how they're going to get there. And they're talking about also specifying maybe a slot and a form factor and this sort of thing. But you can see that they are already kind of tending towards that direction. What we need to do outside of these large companies is see if we have similar systems, who provides these various chiplets and how do you integrate them, right?
Yep. Is there, are these slides accessible to anyone, or like if so,
Yeah.
a link for that?
I'll post a link in the chat.
Okay.
All of these are available on some. I'll provide the link.
Okay, that'd be great.
So. You can go ahead, Marek. I'll find the link.
Yeah, awesome. Thank you. Yeah, no, those are good points. So I'm thinking about how we best do this. I feel like, given all the criteria, I feel that we may not need to go through this exercise of what chiplet's going to be where, because even if we just look at these applications, and I think, like, I like the comment kind of saying, especially towards the, let's say, supercomputing and data centers, there is already a lot of traction and interest from companies to open up an ecosystem there. So what could be maybe reference cases where there is not as much attention right now? And to me, for example, one that may cover a lot of these criteria would be something towards automotive, which would be, like, it is still reasonably high, let's say, data rates, but probably not necessarily terabits in every single package, and would have like a different profile compared to data centers. But So my question to you guys is, how do we want to discuss each of those a little bit and then figure out which ones would be the best 2 or 3 to pick as representative samples, or do we want to do it another way?
Okay, maybe I'll take another minute and throw another slide up to
Okay.
show the power of at least what is a hub plus a bunch of chips, how it can create really lot of opportunities. So can you guys see my screen?
Yep.
So, I mean, this is preview of stuff I'm going to present at the short. So this is a example 3 chiplet system. I'm getting echo from someone. You can see that there is a hub chiplet which is focused on the SmartNIC vertical, and essentially it has a networking port 800 gigabits, and then there are PCI to handle CXL, and then it's using a bunch of wires die to die. There are 2 slots, if you will, to which 2 compute chips are attached. Now, this already is and the SmartNIC guys are providing kind of the software platform and all of this. So the RISC-V can seamlessly attach to it, and the SmartNIC also manages coherency and so on and so forth. This is kind of the simplest version, but where this can go is, depending on the configuration of the hub, you could have multiple slots on it, which are kind of die-to-die interfaces where you can attach scalably many compute elements, or you could have a couple of compute and any other type of domain-specific accelerator. It could be video transcoding, it could be anything. But the point is, you could make the chiplet hub bigger, you could put multiples of them together, and to that, given the number of slots, you can add as many different flavors of compute and domain-specific accelerator. With this simple hub concept, now you have many combinations that are possible, and what this allows you to do is already within this ecosystem, there are compute chiplets. Some others are working on 5G RF type of applications, and yet others are looking at other options. But now you have a platform or a infrastructure around which people can start thinking about what kind of chiplets make sense for any target market and so on. I'm hoping this will help seed the kind of discussions we are having to kind of at least provide some framework for how to think about this, right?
Yeah, thank you for sharing this. To me, like, one of the questions this brings up is kind of like with the goal in mind that we have for the working group, or at least as I understand it, would be to tease out like a couple of different like use cases. And are we like the way you're suggesting this is like even building a platform that is extensible, like you're mentioning that this could go even towards like 5G or something, but based on what you're showing, is certainly also, or seems like helpful towards like data center applications. So, like, are you suggesting we should think about something that can grow to a couple of these different use cases that we already put on the list, or should we rather think about kind of different clusters and then at a high level derive what are the challenges to make those into ecosystems?
Okay, so the idea of showing this was to say, here's one very concrete example of, for smart NICs, what some companies are thinking about and how that ecosystem is forming around it. And this is starting simpler. The bow was a key enabler. We still had to solve some implementation challenges, and that's all the stuff I'll be talking about in the two opportunities I have next week and the following week. But the point is, for the markets that we have identified, automotive, there's a lot of interest to see, okay, if you want to build a chiplet-based solution for automotive, and again, there are many presentations, pick one of those kind of systems and say, how do we make that happen in a chiplet ecosystem?
Yeah, okay.
And then whether the companies that are here have the expertise to build those chiplets, or who else do we need to bring in, and within that context, then take all the stuff that people have talked about in terms of security, this, that, and see which ones are really a problem in that system versus what is more kind of more armchair.
Yeah.
So Suresh, I think this is, I think we're both aligned on the ecosystem approach, right? Because it's the only way it's going to work. So I think this is great. What do you have a time schedule of, or will you be presenting something? I mean, is this already done, or is it still in development, or?
No, so Kash, the thing is, I have a slot in the OCP regional conference next week to present this, but we've talked, Bapi has given me a slot on the Friday meeting, 2 Fridays from today, where I'll have a little bit more time and kind of talk a little bit more in more detail about some of this, and also motivated a little bit more.
Okay, no, I think this is great.
So then maybe also for others, like, what do you think how we should proceed, like, given kind of the high level task of trying to find use cases for chiplets that we could then do a further deep dive on?
Well, Marek, I think, coming from I always like to match a technology perspective with a market perspective.
Okay.
And so I think, based on just a little bit I heard today, already I see there's the computational market where you have the hub a la AMD, and it'd be great to see what would it mean in an ideal world where that's an open ecosystem. We have the SmartNIC hub just shown. We have knowledge of an automotive hub. So I think you got 3 pretty important markets that are ripe for chiplets that demonstrate some of the criteria already around high end, lower end. If there's a 4th market I think we'd want to look at, is there some hub architecture for networking chiplet that brings together optical? So to me, those are already a couple of high runners to explore, would be my suggestion based on it and technology and impact.
Can you explain a little bit more the one with the NIC? Is like what I don't have a grasp of like what like market that would fit in, or like how that is, say, different from compute or automotive or
Well,
switch
typically,
markets.
when I used to track the smart NIC market, I would track that separately from the server market. So I guess when I was talking about compute, I meant server, really. And, you know, that's about a probably $120 billion market today for servers. I'm just guessing. I haven't seen the numbers for a while. The smart NIC market was going into several $billion by this time. And then automotive, I know that the numbers are pretty large, but I couldn't quote a number to you. So if that helps,
Yeah.
I was thinking, you know, those are, and then the other one that's pretty big in the data center networking, it's probably about a $30 billion market today for data center networking. So right away, we've got a couple of the bases covered, a lower end technology with high market share or impact from automotive, especially with the move to electric vehicles, right, and the computerization of vehicles. And then, so anyhow, those are my thoughts around. Right away, I could look at the criteria we identified and put a couple for maybe a deep dive exploration on what a chip. I like the concept of chiplet hub. I think that's really good because you have these ecosystems that could come together for each of these use cases, and now we can dive in deeper. Anyhow, just sharing my thought.
Yeah. Okay. Could you maybe just still for the smart hub or the smart NIC, like where would I buy a smart NIC in which market, like what application?
So, Marek, smart NICs are used extensively in the networking space, right? The whole point is they're all, I mean, Bapi, you want to say something? You have some familiarity with that space, right?
For Metronome, yeah, actually. Metronome used to be one of my clients when I was an analyst. I don't know if Bapi was there at the time, but I can tell you that the two main applications for smart NICs today are in the data center, as Suresh is saying, and the other one is telecom. Quite a lot of work being done there with 5G offload. So I like the telecom angle as well, personally, because of that implication.
Okay. To me, they do still look somewhat similar to switches, or like kind of like similar in terms of like the needs, but maybe I'm wrong there.
Maybe technologically they are. I don't know what kind of hubs would be there, but switches, you know, you tend to have the switching ASIC, and then you've got to connect it to some sort of optical PHY or some sort of PHY. The smart NIC is much more like a computational infrastructure, in my mind.
Gotcha.
Well,
yeah, Marek, yeah, I was just going to add that the switch guys are already using chiplets, but they are like a closed system, right? Like a Broadcom would build a large, like, you know, their latest one uses chiplets and it uses optical and all that, right? And you can actually swap out long reach SerDes chiplet with an optical chiplet. So they're already kind of in that process, right?
Well,
so it's part of their product.
So isn't that exactly what we're looking for? We're looking for use cases where maybe someone's doing it in-house in a big way, and now we want to break that open in a way that's a good sign, no?
Yeah, I think it's such a specialized, very, very high performance market. I think it's going to be difficult. Just between us, I think it'll be very difficult to crack the switch market. But obviously the NIC market makes perfect sense. And as you say, there's a number of, so that's a natural, and that's why Suresh and the Alpha Wave, you know, all those guys are you know, teaming up to do that. I think that makes perfect sense. And I think also to your point about automotive, right? They're talking about hubs, right, or different zones, if you will, right? So you could certainly see chiplets playing in that space. I think that makes perfect sense. Yeah.
So one other thing I will suggest is to Cliff's point, if it might help if we all reviewed the Yole or Yole Group's presentation from the Chiplet Summit. they've also broken down kind of the different markets and where things are headed. They are predicting chiplet between 180 to 230 billion market within the next 5 to 8 years.
Okay.
Or even help if I think Cliff mentioned he knows someone there.
Yeah, we could actually invite Tom Hackenberg to come to a call if we wanted to from Yule. I'm pretty sure he would.
Yeah, I mean that may actually be a good starting point.
I think that would be a really yeah. Marek, sorry to jump in. I was just going to agree with that comment. I think it's great. That would be great to do.
Okay, maybe Bobby, I don't know if you want to bring him to this subgroup or ask him to come to the earlier meeting on a Friday. I think we had already talked about it, if I'm not mistaken, and maybe we can get him sometime in May to join us and give a short presentation to everyone on what he did at the Chiplet Summit, and then open the floor for questions.
Sounds like a plan. We can pick a date in May.
But from my standpoint, it would be nice for this group so we could actually ask questions and sort of be more interactive rather than just the slide presentation. Anyway, that's because I'd like, it'd be nice if they actually have more in-depth data than they're probably just in slides, right? If we want to drill down into like where in the automotive or where in the data center, or what do they think of this? You know,
well, we could always
anyway. Yeah, so I think an interactive one would be really interesting, right?
Following up to what you're saying, maybe we have him present some of the generic overview slides at the end of the 11 o'clock meeting, and then have him come in here and spend a few minutes with us in interactive. And if we have a half a dozen questions that we'd like him to prepare for, we could send them over in advance, and you'll get more from him. We just put him on the spot, of course.
Right. No, that makes sense. That's a great idea, right? To give him 20-30 minutes to present, and then hopefully maybe half an hour with us, and we use this time wisely, and it should be a good conversation. So that'd be great.
Yeah. Okay. Yeah, no, that sounds really good. So, Kash, I wanted to ask you, kind of coming back to your presentation just now. I feel like all of the examples that we have on here are still like can be fairly high performance. Like even in automotive, if you think towards cameras and high definition and so on, there can still be a lot of data. And you talked about the interest of also having lower bandwidth links. Do you see any other big markets where you would say this is maybe a use case that we should consider that's not on here? Kash, you're on mute if you want to speak, or if not, that's fine too.
Oh, sorry, I was speaking.
Okay.
Yeah, automotive is definitely an area that we have some interest in, are talking to some people. As you know, they're all moving to this zonal architecture. And yes, there's a lot of data flowing. There's also some very slow data flowing, right? So
yeah,
when you have a button pressed or a brake pressed, or and it's more complex than just the current standard, because you've got time sensitive stuff, or which has to be prioritized, right? There's functional safety that comes in, so it's a complicated question. And I was actually talking to someone about advanced packaging, and they was saying there's no way that the old school auto guys are even remotely ready for that. They're going to want, maybe they'll do it, standard packaging, right? So anyway, chiplets are a really good application, because we think of automotive as really high volume, right? But it's really not when you look at each car, right? So if you look at the high-end cars, right, some of these people only ship like 10 or 20,000 a year, right? So that's low volume, and then they want differentiated solutions, so not the same ASIC for everything, right? So there's there's a lot of complexity in that space. So I think this is a very interesting space. So I would be interested to see YOLO's input on it, and also as we engage with clients. But definitely automotive would make a and for example, so we're in my presentation I talked about an ASIL compliant RISC-V processor chiplet that we're planning on doing, and that's obviously targeting this space, right? And
Okay.
yeah, and obviously programmability is also you may know that FPGAs are used in cars as well, even today, right? For some flexibility and things like that. So yeah, I do think that's a good one. And then I think the other, yeah, I think we've got enough, right? Because otherwise we release, you know, so we got the SmartNIC one, and then automotive and compute, and I think that's the 3 is more than enough for us to focus on. I think
Okay.
personally, I think the switch side is, you know,
The other one that I'm considering, like towards like just broad categories like industrial and consumer, and where like I think both of these would also potentially even like sometimes be less than like or also on the lower bandwidth side, and if that's something that resonates with others, or if we should kind of focus on the top 3 here that we have so far, or debate. But like I also personally think that like the smart NICs and switches seem kind of like if we have to pick 3, I would like try to take 3 that like look different in every way, and to me they don't look different enough, even though I do understand that this one has the optical side of things.
right. Yeah, I think you could take switch out. I just don't see us playing in that space. I think you're right. In terms of an open system, right? It's
Yeah.
the peripherals are going to be open, but I think the switches
Well,
themselves, it's very difficult. Yeah.
Cash, you're thinking of only the networking switch, right? But there could be other types too.
That's true. Yeah.
Other comments on this list, or like things you think, like yeah, people that may have not spoken yet, what do you guys think about this list, or other things that should maybe be on there?
I think Cliff had mentioned 5G and mobile, right? I think that
Yeah.
infrastructure should be on this list, because that's a big use. That again, those volumes are high, but they're not consumer type volumes, right? So and that is an open system where I think chiplets will play in that space.
So is that I'm just trying to see, because we also put telecommunication as one aspect for smart NICs. What do others think about like 5G, 6G applications?
I agree with Cash. It should be its own as a market.
Yeah.
And I would third that as well, especially in the base station arena where the volumes are, yeah.
Okay.
One quick thing I want to mention, in automotive, we've captured it above, but sensor fusion is one of the huge functional subunits, right?
Right. Yeah, obviously.
Sensor fusion and ECU as just reminders in that.
What is an ECU?
Some computational unit.
Oh, like a
engine
like
computational unit, I think.
Okay.
Engine control unit.
Yeah, it used to be just for the engine. Now it's used for, you know.
Yeah, everywhere.
Basically everywhere. You know, your your sunshade or whatever your what do they call it? It has an ECU.
Okay. So then I guess I would. So to me, this already looks pretty good in terms of the covering some things. Now the question is, do we want to we have in total 5 on here. I know it's kind of hard to pick. My comment would be that I know compute is a huge market, but we've also talked about how there is already a sign for example from AMD that have their own interests in already creating something which is likely more analyzed. Should we go with all of these, or which one do we take out? Because I personally would vote for taking switches out, I guess.
I would agree with that too.
Okay. So then I'll just grade this out for now. So then that still leaves 4, but I think
so
they are all quite different.
Yeah, the compute server, I mean, that market's been served by chiplets for several years now.
Right.
Right.
I think you could also say compute/storage, because compute and storage are kind of they're kind of becoming sort of symbiotic, right? It is a massive market. So
a lot of times the difference there is just the software.
Yeah, exactly. So it's.
I guess the only question here is yeah, go ahead.
No, all I was saying is, since somebody mentioned storage, the big 3 buckets are compute, networking, and storage, right?
Mm-hmm.
Always.
Probably the one difference. Oh, I keep doing the one difference here is probably that when we talk about the compute market being adequately served with chiplets, that's mostly just, or to my knowledge, just vertically integrated companies. So the question there could be, what could we do to make that kind of a more an open market? But I guess towards even UCIe there, I think there's definitely an interest, and I can see this happening even on its own in the meantime, because there is, as you can see by the number, it's a huge market.
Well, I don't think it's a done deal, right? Because the big guys are doing it. The RISC-V guys would be very unhappy if you told them that.
Yeah. Okay. Okay. So then I guess I mean, I'm happy to keep the 4 there. The next question is, how do we want to go about working out some more concrete things for us to do, either analyzing this, one way would be for maybe people that have a good background in any of these to prepare maybe 15 minutes to just explain what they see as where the market stands and what they see as the challenges, and then we could go on discussing that, or yeah, what do people think?
I think there are already players in this space, right? From AlphaWave participates on this, right? The Suresh, the other guys that are working with you, right? So there's a group that's already focused on this space. It would be interesting to. There's a competitive element, I guess, but on the other hand, there's, when are you guys becoming more open?
Well, I guess the way I would look at it is, if there is a few big players that are doing this for their own purpose, it's kind of, if you go back to the early days of open networking, where you had, Junipers and Cisco's of the world, and then we had open networking come along and try to open it up and disaggregate. It's kind of the same thing that we're doing here. So a good indicator that there's something right for disaggregation is the fact that it's being done internally in a big way, right?
Mm-hmm, mm-hmm.
Yeah,
it's a good point. So yeah, no, I think that this is there should be a session on this, but it needs to involve some of the people that are actually actively, developing chiplets. I mean, like this IO Hub chiplet, right? It's obviously targeting into that space and the smart NIC space, right? So.
Okay. So maybe one other thing would be just coming back to our initial list of ideas. So I'm maybe not clear on like what our outcome could be. And I think some of the things that we talked about was this idea of having best practices for business cases or these compliance checklists. Do you see those as being as being outcomes once we go deep enough into any of those cases? Or would you have another, like something else that you think could help kind of understanding people that come into this market that we could prepare once we look at the, because I feel like right now it's more of an informational, like gathering information. That could also be a valuable exercise. Not sure.
Yeah, but so I think that going back to your list, right? It was the business paper and what are the challenges, right? So
yeah,
I mean, Suresh and his group are further along than anybody else that I know. So that eventually, hopefully, that team will put that together, right? And say, look, we architected it this way, and this is what the challenges were, and these are the challenges now, because they haven't taped out yet, right, Suresh? So you still have to go through that hurdle, and then what are the costs, and because this is something that people actually want to know, right? And
yeah,
what is the real cost to do this IO Hub? Because you guys are sort of breaking ground on that, right? As sort of an open,
Yeah.
It being an open chiplet, so it's a great use case, I think.
So
I think, yeah, no, go ahead.
I'll say it a little bit differently. My whole thing is, or at least what I want to convey when I do the talk is, let's not just focus and say, oh, there are problems galore. It's more, you can still build compelling chiplet solutions. You just have to start a little bit small and with organic substrates and with some clever architectures. And obviously with one of the key things is having die-to-die interfaces, which was kind of very critical to even have this as a concept outside, right? So you can still do pretty powerful systems given where we are, and then advanced packaging, and then the security, all of that is once you define these architectures, what specific issues those are will become very clear, and that's what we can delineate here.
Okay. So I guess what I'm hearing is we would go back a little bit to, from at least from Kash's perspective, outlining or working out the challenges, but now not general ones, but rather for a specific use case. And then to your point, Suresh, to then say, like, as of today, like, this is what you can already do. Like, it may not get you there 100%, but instead of just saying it's impossible or there are too many questions, this is what you can do today to answer the questions.
Exactly.
Okay.
Yeah, because there's a lot of hype about 32 gig per link, and
yeah,
45 micron bump pitch everywhere, and nobody knows what it's going to cost, and what is there are really not that many people doing it, right? I mean, at yesterday's presentation, like Broadcom had a guy present, and they've got one design in flight with hybrid bonding. It's a test chip, like with 10 micron pitches and stuff. So it's definitely happening where people are trying something out, but it's not a mainstream. So obviously advanced packaging is starting to become mainstream for a very narrow niche of applications, right? And I think that the real world is that 80% of initial applications are probably going to be standard packaging. And my concern, and I think Suresh's too, right? It's if people are aiming for 10 nanometer hybrid bonding in 2 years as a general purpose, it's not happening, right? There's a real world where the costs really are incredibly challenging, and how do you even test all this 3D stuff? And people were like, oh well, we don't know, and so it's incredibly. So there has to be something which is more grounded, I'm hoping, right? So which is like, okay, I want to do it now, I want to start now, and what can I really do and get into production in a couple of years? It's really going to be the standard package stuff, I would think, right?
Yeah. To put it more starkly, some of the large companies have been doing this for 10 years, and 3D ICs to them also is very challenging, and they have to do test vehicle after test vehicle to get everything right. To think that we're going to do that in an open system is a little bit, I think, ridiculous. And we should start with simply thinking of what traditional SIPs are. How can you do that with chiplets? And that's well understood and still add a lot of value, and then move to the next stages.
Okay.
Instead of conflating all these things and saying chiplets, 3D IC, this, that, and paralysis.
Hey, so I just want to go back to that list for 1 second. There is one thing I think we're missing, which is either a customer or a champion. So if Facebook or Google or somebody said, oh, if you guys are developing a reference architecture for an open architecture for a switch, we're on board, as an example. Then, or we have some, in my mind, whichever one gets pulled from someone. If Ericsson came around and said, oh, you guys want to do a base station, we can, or Intel came around and said, if you're going to do a chiplet-based base station, whether it's, in fact, we should be open to whether it's UCIe based or Bow based, honestly. But having a champion for an open architecture, in my mind, is going to be a big plus.
So, Bapi, question for you is chicken and egg. Should they tell us, or should we come up with something and ask them to vet it, refine
definitely
it?
the wrong answer. We come up with something, and if you show the people a wrong answer, they're almost always willing to tell you what the right one is.
Okay.
Good point.
It's definitely we need to come up with, but we need to identify potential customers and use or champions for each of these, and go to them and say, hey, we're thinking of this is the open architecture we have in mind, and see whether anybody bites anywhere. Like, if Mercedes comes along and says, or BMW has a center and says, oh yeah, automotive, we're kind of interested. That automatically wins in my mind.
Bapi, corollary or complementary to what you just raised, if they say, yeah, we bless it, then who bells the cat? Or will that automatically have people go build those chiplets, or is there any thought on that?
I think it gives our definition and proposal much more credibility when there's a champion or a customer. And eventually we get to the building part, but at least right now, rather than us pushing outward, it's somebody pulling along with us, right? To Cliff's point earlier about open compute, I think one of the interesting things that really helped was Facebook sitting on everybody's head and saying, hey, I want a modular server, I want a modular data center, I want something. And that pull brought many people along for the ride.
Yeah, that's kind of so it's a good point that you're bringing up, and that was my next question. What do we see as kind of even the intermediate outcome of this? And it sounds like from what you're describing that we're really thinking through the like kind of like based on the requirements of that market, what should a system look like, and make some recommendations perhaps. And then, but it would only make sense if somebody that is in the market says like, yes, those are good recommendations, and hopefully go along with actually implementing something along those lines.
100%. And the one thing I keep forgetting to add here is HPC as a separate thing. HPC, I know we can get pull. That part I'm pretty confident.
Okay, and HPC being towards the supercomputing.
Yeah, but a distinct segment.
Yeah. Okay, so now the question is that we have so many. I guess we basically need champions for each of those to say who's gonna lead kind of an analysis of that space and work out even a strawman proposal. And so yeah, that to me looks like a next step then for us.
Yeah, so we at least develop some strawman proposals for each of these, and then identify who a potential consumer is, right? For HPC, it'll be the DOE. For automotive, there's some guy who reached out from Bo about automotive. I forgot his name. We can see whether he can take it around to his company. So for each one, I think we got to identify a potential person, a few people to reach out to, and maybe Cliff. We have some names in the larger OCP group we could go ping with it.
Okay, so I know that we're at the top of the hour. I think this definitely helped us clarify a little bit where we want to go, and then I would say we just pick up next week exactly at this point. What specifically do we do? Do we do all of them in parallel or one at a time? And then how do we go about getting people involved that are major players in the space? Does that sound good?
Yeah, sounds good, Marek. Sounds good.
Awesome. Yep. Okay, then thanks everyone for your for joining today. Have a good weekend.
Bye.
Thanks Marek.
Everyone.
Hey Marek.